First, we'll go through using these two equations, right? Being able to get degrees Celsius and degrees Fahrenheit. So equation 1, degrees Celsius equals degrees Fahrenheit minus 32, right? Notice the parentheses, and then times 5/9. Equation 2, right? Degrees Fahrenheit equals degrees Celsius times 9/5. Again, take care of the parentheses, plus 32. Right? So depending on what we want, we use equation 1 or 2. Right? So if we do an example with 3 degrees Celsius equals how many degrees Fahrenheit, right? Then I want to use equation 2, right? Because I want to get how many degrees Fahrenheit. So where I see degrees Celsius, I just plug in the 3. Right? So it ends up being 3 times 9/5 plus 32. Because of the parentheses, right, I do this first, and then I add 32. Right? So if I do the math, right, you plug this into your calculator, you get 37.4. Right? So 3 degrees Celsius is equal to 37.4 degrees Fahrenheit. Okay? And we'll do another one more example. We have 20 degrees Fahrenheit. How many degrees Celsius does this equal? Right, so in this case, we're using equation 1. Right? So we plug in the 20 where we see the Fahrenheit. Right? So we do 20 minus 32. We do this first, and then multiply by 5/9. You'll note that it's a negative number, which is fine, right? Just means it's really cold. So that's converting from degrees Celsius to Fahrenheit using these equations. The next one, right? So all these were kind of leading up to, in some ways, how to deal with fractional scales, right? So you did go through some how to convert, right? And in your book, right, if you look in the appendix A1, it shows you different, this is basically converting in between, say, if we want to look at meters here, because we're looking at length, right? So you have prefixes tera, giga, mega, right? They all mean something like 10 to the 12th, right? If you look more closely, right? Centi, say, which is 10 to the minus 2, right? So we're basically trying to convert within that metric system. Right? So we mostly deal with length, right? Because we're going to be looking at maps. Right? So let's convert how many, we said 1 centimeter equals how many meters. So from our figure over in A1, right, we know that the centi means 1 times 10 to the minus 2. Right? So when you convert this way, right, if you're using kind of a conversion in what I call dimensional analysis, then the prefix, right, the minus 1 times 10 to the minus 2 always goes on, say, the meters. Right, so the right, so you put here. So 1 centimeter, and then 1 times 10 to the minus 2. Right, so when you multiply all that out, it equals 0.01 meters. Right? If you want to know how many 3 meters equals how many centimeters, you flip this. Right, see how I flipped it? Right, so it's you end up dividing by 1 times 10 to the minus 2. Right, which 1 times 10 to the minus 2 is 0.01. Right? So 300 centimeters. So our looking at our map scales, right? So map scales, right? So you'll see it up here, 1, and then a colon, and then 200. It's a scale of the map. And when you do your problems, right, the scale varies. It may not be 1 to 200, it might be 1 to 360,000, right, whatever the number is. Right? And it's the same procedure, you're just using different numbers. So the first number, right, the 1, is indicating what's on the map. Right? So it's a way to relate to what's on the map to what's on the Earth's surface. Right? So if we were to go out and go to the field and see what we would find, what's representing this map. Okay? So if they ask you a question, right, which they will, right, so say if they ask 1 centimeter equals how many meters on a particular map, right, that has this particular scale. In this case, it's 1 to 200. So we set it up, right, so we put 1 centimeter on the map. Right? So this is the same as your map scale, right? So it's a way of you kind of converting, right, between what you see on the map and what's out in the field. So we use this, right, the map scale is our conversion, right? So because we have this 1, right, 1 on the map, 200 on the Earth's surface, right? And we'll go centimeters to centimeters. Now this could be inches to inches. It's as long as the two are equal when you first start out, right? So you could put any type of units. So we use that to convert, right? And then we want to know how many meters, so now we have to convert the centimeters into meters. Okay? So it comes out to be 2 meters on the Earth's surface, right, if you do all the math. Right? So what it's saying is 1 centimeter, right, on the map represents 2 meters on the Earth's surface. Okay, one of your problems they might ask you within mastering is more complicated. Right? They throw in, it asks you, say, if you have a map that's, say, 10 inches wide and 10 inches long, right, how many miles does this represent? Right? And then they say again, assuming you have a scale of 1 to 200. Right? Again, scale could vary depending on what problem is in the mastering. Right? So to get first process is we want to know what's on the entire map, right? We just multiply the width times the length together. Right? So 10 times 10 is 100. You also have to kind of carry the units with it, right? So if you have inches, right, then inch times inch is inches squared on the map. So that's important to carry it, right? Carry this square, right, because it ends up in here. Right? So now we know, okay, on the map we have 100 inches on the map. So we use our scale, right? So it's asking us how many miles on the Earth's surface, right? So 1 inch and 200 inches on the Earth's surface, right? So we use our scale to convert from what's on the map to what's on the Earth's surface. Now, because this is square, right, we got to put this whole thing square, right? So in essence, this 200 is square. 200 square is 40,000. 1 square is just 1, right? And now we still need to get to miles, right? So we know 12 inches equals 1 foot. We still have to do the square. So the 12 becomes 144. And then I'm telling you here, right, that there's 5,280 feet in 1 mile. That's just a conversion that you could have looked up on the internet. And again, you got to do the square so that units cancel out. Right? So 5,280 square is this number. Right? So I'm going 100, right, times 40,000 divided by 144, and then divided by this very large number. So it comes out to this really small number, right? 0.000996 miles square. Okay, so that should help you with the problems.